All right, I'll get started with the introductory part of this webinar. First of all, thank you so much for those of you that are joining us today. We have a great session in store for you in this GCE Ask the Experts interactive webinar. We'll be taking both pre-submitted questions as well as live questions throughout the webinar. And we have an expert panel here today who I'll introduce in just a moment. The topic for today's webinar is operational response to radar monitoring data. So we'll focus our questions on topics such as identifying, preventing, or managing instabilities using radar data analysis, alarms, and trigger action response plans. So this webinar is brought to you by the Geotechnical Center of Excellence at the University of Arizona. If you are unfamiliar with the GCE, we are industry-funded and member-led. We are an interdisciplinary center working across the University of Arizona within many different departments, as well as across industry to produce collaborative geotechnical research and education with the goal of bridging gaps within and between academia, industry, and fields of study. If you'd like to know more, check out our website, follow us on LinkedIn, or give us an email at the address you see at the top of the screen. And just to mention that many of the panelists who are here today on our expert panel are presenters in our geotechnical radar monitoring course. So this session is aligned with the topics that are covered in that course. If you're interested to know more about this course, you can scan that QR code or contact the GCE for more information. And I must, of course, thank our member companies who, without their support and funding, sessions like this would not be possible, as well as all of our course development and the great research that the GCE is working on. So these are our member companies. We want to make sure to give them a big thank you for their support of all the work that we are able to do here at the GCE. And now to introduce your panel and who's here today. Myself, I am Jillian Noonan. I'm Senior R&D Engineer with the GCE, and I'll be your moderator today. Helping me out from the GCE, I have Benjamin Meyer, who is a software engineer. Benjamin, thanks so much for helping out today.
Thanks for having me. Welcome, everybody.
Also, Christian Ortman, who is a computing sciences engineer with the GCE. Christian, thanks for helping.
Thank you, Jillian. Good morning, everyone. Thank you for attending today's webinar.
And now it's my honor to introduce our expert panel today. We have Greg Abrams, who is Manager of Geotechnical and Hydrogeology with Rio Tinto Kennecott Copper at the Bingham Canyon Mine in Utah. Greg, great to have you here today.
Morning, Jill. Hi, everyone.
Also with us on the expert panel is Paolo Farina. Paolo is the Managing Director for GeoApp based out of Italy. Paolo, it's always great to have you on our panels, and we're glad you're here today.
Hi, everyone. Thanks, Jill, for the opportunity. Greetings from Italy.
And joining us on our panel is Pat Jenks. Pat is the Geotechnical Engineering Manager with Nevada Gold Mines. Pat, really glad to have you here today. Thanks so much for your time.
Good morning, everyone. Thank you, Jillian. Enjoy the seminar.
Also on our panel, we have Derek Rubish, who is Senior Geotechnical Engineer with BGC Engineering, as well as one of the presenters in the radar monitoring course. Derek, thank you so much for your time today and for joining our panel.
Yeah, hello, everyone. Happy to be here.
And we have Charla Kotsi, who is Group Geotechnical Engineer. Charla is joining us from Roytech Mining in South Africa. Charla, thank you so much. So good to see you and glad to have you on the panel today.
Thank you so much. Always such a pleasure. Welcome, everyone.
All right. So now just a little bit of information for you, the participants, on how you can interact with our panel today to ask questions. First of all, this is a webinar, so you are muted and your video is off. If you'd like to ask a question, you can enter it at any time into the Q&A button, which is on your Zoom control panel. Looks like this button here you see. So you click on this Q&A icon, and then it'll open up a window where you'll be able to type in a question. You'll be able to see the questions that others have entered. You'll be able to upvote questions using a thumbs up. You can enter questions anonymously by clicking a little box, I believe. So make sure you utilize the Q&A function throughout the webinar to enter your questions related to operational response to radar monitoring data, and you can start entering them at any time. We will be going through some pre-submitted questions to start off as well, and maybe alternating back and forth between pre-submitted and live questions throughout the webinar. And we are recording this webinar. We'll post it to both the radar monitoring course site and to the GCE's YouTube page following the session. There's also the chat function in Zoom. The chat is more informal. So if you'd like to go into the chat, say hello, make any comments, you're welcome to use the chat as well. But we do ask that any questions for the panel go through the Q&A so that Benjamin and Christian are able to sort through those, and we'll bring those up on the screen. Okay, so that is all of the introductions and the instructions. So if we're ready to get started, I will pull up the first question for our panel. All right, and the way this will work is I'll read out each question, and then I will open it up to the panel, and whoever would like to jump in is welcome to start off, and or I may call on you, and you're welcome to accept or pass. All right, so our first question is came in from the GCE email, and the question asks, I have encountered sites with multiple complex TARPs, TARP being a trigger action response plan, in place, and I was concerned about how the complexity might hinder a response. So is simplicity often considered when designing TARPs? And if so, where can simplifications be made, and where should they be avoided? So just to kick this off, I think maybe Greg looks eager to start, and I will call on Greg to start off, and then we'll pass to the rest of the panel.
All right, thanks, Jill. Yeah, this is a good question because TARP efficacy, or how efficient your TARP is just so important. And it's something we've been learning a lot about in the last 12 months or so. And simplicity is definitely, it's a really important thing when you're trying to implement your TARPs. I mean, the first thing that comes to mind is what are your triggers? Quite often you might have, we're going to, we might have a velocity trigger. We might have a velocity ratio trigger and this and that. But even if you think about a velocity, you really need to spell out, is that on this radar? Is that on that radar? You might have multiple radars with multiple, so they're going to have different lines of sight. So your velocities are all going to be different. Are you going to use your prisms? Are you going to use your GPSs? Are you going to use slope distance, or are you going to use 3D displacement? Over what time period? So there's so many different ways in which you can even calculate just a velocity and then a velocity ratio and so on. So getting that clearly spelled out up front is going to make everything a lot easier. And it will also add a lot of it'll make the TARP much more defendable, so that if something happens and an investigation goes on, and you could say, look, yes, here's the TARP, it got approved and we followed it. It's really tricky to defend your actions when you might say, look, we're going to trigger a TARP 3 at 2 inches a day, but there's ambiguity as to which instrument you're actually referring to. So I think calling it out ahead of time and really making it really clear what instruments you're gonna be triggering on is good. Something we've found is velocity is a very good one to go on. Velocity ratio is very nice, but once again, you need to really spell out what time period you're gonna be calculating it over. And then the second part where we got about where should we avoid simplifying things. This is tricky as well because you also want some judgment to be made. You know, you want your geotech team to be able to make a judgment call. You're never going to get this TARP absolutely, perfectly idiot-proof. There's always going to be a judgment call. You may think you've foreseen every single outcome, but it's very unlikely. So there will always need to be a judgment call, and I think that also needs to be written in. So it is a case of finding that balance so that the team can exercise some expert judgment, because that's what we're there for.
Good. Any other comments from the panel? Pat,
Yep.
I see you've unmuted. Would you like to go ahead?
Yeah, Jillian, just some things to consider here is who the audience is, who's going to be executing the TARP with respect to the level of. We have a couple of operations in our portfolio where we don't have a geotechnical engineer on site, so the TARPs had to be tailored to the operations team so that they were understandable to them and they could execute on the triggers. So things like that are going to be critical to keep in mind. The other thing is that we be mindful of is the complexity of the geotechnical and geological conditions. You know, you may have portions of your high wall that were designed for different design acceptance criteria. So that would also need to be considered as in the complexity of your TARP as well. You may have portions of the wall that were designed for a DAC of 1.5, for example, for various conditions, whereas other places where you have good understanding of the geologic and geotechnical models, you may be mining at a factor of safety of 1.1, and you may need to have a little more complex TARP. But keeping in mind who the audience is, who the personnel are that will be executing that TARP are going to be critical aspects of that.
That's a really good point, Pat.
If I can add a comment on top of this valuable point of view, I think we should start from a very simple approach. When you don't have any specific information about past instabilities and expected velocities, I think it's important to start with a very simple approach. But then day by day, later on, when you gain more understanding of what are the different let's say, instability mechanism, the different type of failure, brittle or more plastic, it is important to differentiate, okay? Differentiate in order to take care of different possible risk scenarios, because you may have domains where you have very brittle instabilities, bench scale, multi-bench scale, and of course you have to manage them with the appropriate threshold of the radar. And you may deal also with large-scale instabilities lasting for weeks, months, or years. And of course, you cannot rely on the same type of rules, to the setup of a radar threshold. So it's really something that it's a process. It's a learning process. And as Greg was saying, it's important that we keep a record of the changes that we do. We define these threshold based on some arguments, and then we try to improve them. Because if something happens, we have to, from a liability perspective, it's important to show that our decision were based on argument, not just engineering judgment, which could be not good enough, to in some situation. So I always recommend to start with very simple standard, let's say, TARPs, and then to develop them, trying to, let's say, fine-tune them in accordance with the situation you are dealing with, the different material you have, the different mechanism, failure mechanism you are dealing with.
I would also say, irrespective of whether or not it's a complex or simple TARP, training is very important, making sure that your teams and your crews are very well versed in what the TARP says and what the expected responses are. Also doing some test runs can prove very valuable, especially if you have a high amount of turnover on your team and new folks are coming and going.
All very good. Excuse me. All very good points. Pat,
Yeah,
do you have something to add?
Yeah, just a funny anecdote to add on to what Derek was saying. The training part of that critical, and running drills is critical. Once a year at our operations, we run a emergency response drill for clearing the pit. And I can tell you that, making sure that there's good communication on when you're running these drills is critical. I remember being out on the high wall one day. I'm walking down one of the slopes that was deforming and observing some of the cracks, and I get this phone call from the ops manager saying, "Hey, we're having a high wall failure." "Oh, really? Where?" And he goes, "Oh, the Chop East high wall." "No, we're not. I'm standing on it." He says, "No, we're having a high wall failure." And I said, "No, Mike, we're not having a high wall failure. I am walking this high wall." So, making sure that we're communicating when we're doing these things and practicing these drills, it's really an important aspect of the operational side of this business.
Yeah, no, it really is. And that just made me think of the other simplification thing is your isolation plan for every tarp. Obviously you will have an isolation plan. And if anything's got to be simple, it's got to be that. Just so that dispatch everyone knows this is where we'll be isolating and this is what we're going to do.
All right, great. Thanks for the discussion on that question. And thank you for the great question. If there aren't any final comments on this one, we'll move on to another. We have a live question that's come in. And I do want to just remind everyone that is attending this webinar live, you are welcome to enter your questions at any time throughout the webinar. And you can do so by using the Q&A button that is located on your control panel. All right, so I'm going to pull up a question here that came in from Murat. And we have just sort of shortened it a little bit, Murat. So I'll read the question and then open up to the panel for discussion. So the question is asking, are there certain standards or thresholding values for installing alarms on a tailings storage facility, TSF? We plan to utilize velocity and inverse velocity alarms. Are there any other methods we can utilize with radar? What about alarming with prisms? Is there a standard for this? So is there anyone that would care to start with this question from the panel? I see Derek. Would you like to start?
Sure. Yeah, I would say in terms of a standard or a specific threshold value, it would be very difficult to define one threshold value for a broad range of sites, but you can infer a kind of a range of values likely from past experience on other sites and evaluating what your radar data is doing, and to kind of hone in on a threshold value in that regards. But oftentimes it's very site and location specific. With tailings dams specifically, you're not expecting them to move or deform much, maybe a little bit during construction as things settle, but you're less likely to be monitoring kind of an active failure situation where you might be more likely to occur in an open pit environment, for example. So oftentimes what we would recommend for evaluating threshold values for a tailings facility would be to evaluate kind of what your baseline noise is for the particular radar unit or piece of equipment that you're using, and defining some threshold close to or slightly in exceedance of that noise so that you're not getting reoccurring false alarms, but you're kind of close to that range in terms of any appreciable or actual movement would foreseeably be recorded and tracked by that piece of equipment. So I think there's definitely a learning period that's required when you commission one of these pieces of equipment at a site instead of just one plug and play value.
So I think background noise is the first answer, as Derek just said, in order to start with some numbers that in order to identify areas where velocity is showing anomalous values compared to the background noise. Then, of course, it depends on the tailing storage facility you are monitoring, because if it is a recently constructed site, you may expect to have settlements, even to have some horizontal movement, not only vertical settlements. Especially there are areas where still in the upstream construction method, the upper raising are settling a lot because they are constructed above, on top of a significant depth of tailing material. In general, I think radar could be good, especially if the coverage, I mean, the surface of the tailing dam is not covered by grass. If you have grass or vegetation, of course, you may have significant noise, and then that could hamper the reliability of the radar data over the long term, probably not in the short term, hours, days, but if you accumulate data longer than a few days or weeks, you may end up with some noise induced by the temporal decorrelation of the radar signal induced by the vegetation. For sure, prism are something to be used, and on prism you can use the very same method you use on radar. So check for the background noise, and then try to define the threshold at least 2 times or 3 times the standard deviation of the noise, and then go ahead like this. I definitely recommend to use INSAR as a method to identify areas of potential concern, trying to identify long-term progressive trends, something that you can do by running some massive inverse velocity analysis, or simply looking at manually at areas here and there. Because for the failure mechanisms that are developing in a time frame compatible with the INSAR delivery frequency, you can identify progressive trends, and this is where you may expect to have troubles. Okay, that's my recommendation.
I think just to add to those very valuable points, one thing to think about is that when utilizing an inverse velocity type tool, the information you get from inverse velocity is only as good as the data that you put into it. Especially leading up to collapse, you need to continuously update those calculations, as the data is coming in. Something that we can also utilize is not just the measurement data captured by the radar system, but looking at the signal quality of the data actually coming in. So looking, for example, at the amplitude, we could also call it confidence, which is the scan-to-scan coherence, or the quality of the signal of the targets being measured on the actual TSF or the pit slope. And then also looking at what we call flagging. So if that target has continuously produced poor quality returns, you actually are able to look at portions of the slope or the TSF that might not be necessarily accumulating a movement per se, but we know from a signal quality perspective that there is definitely something going on with that portion of the slope. So it's kind of a two-pronged approach. What is the measurement component, but then what is the signal quality component? And I definitely agree with what Paolo says. INSAR is probably your most useful tool for TSFs. It informs where you need to put your ground-based radar systems, and then where you're going to set up certain equipment and monitor certain areas so that you're actually utilizing your equipment to the best of its ability, essentially. And then also choosing what kind of equipment do you want to utilize. There's a whole range of different kind of radar systems on the market, and some perform actually a lot better than others. Also thinking about the length of the database wall folder, or that you actually want to be capturing for certain campaigns.
Yeah, just a comment on subsurface. I think subsurface instrumentation for a TSF is going to be critical here. Whether you want an IPI, an in-place inclinometer, or shape arrays, I think where the shearing is within your storage facility is key. Obviously, and you need your VW piezometers in there, your VWPs in there. That's going to be critical for any TSF. And inverse velocity, it's fine, I suppose, but at the end of the day, with tailings facilities, you don't want them to collapse. So, and I would be surprised if the consequence is such where you could tolerate a collapse. So, it would really be early warnings, that early movement that you're trying to detect here, which goes back to the INSAR and that sort of stuff. So just think about what the goals are and any consequence of a tailings collapse.
Right. Thank you so much, panel, for that great advice for this question. And thank you, Murat, for the question. While we're on the topic of alarming, I'm going to pull up another question on alarming. And this question asks, how do we avoid alarm fatigue? And then a second part to the question is, how is noisy or ambiguous radar data incorporated into alarms and or TARPs? So alarm fatigue being like the story of the boy who cried wolf, where too many times and you start to become desensitized to an alarm. So how do you set your alarms to the right thresholds in order to not produce alarm fatigue for your operators? So is there any of the panelists who wish to start with this? I see Paolo, you have unmuted. Go right ahead, please.
My typical suggestion in this case is to start to set up the alarm in the first days, first weeks, just not as official alarms, but to have a training period where the user, the geotechnical engineer can become familiar with the reliability of the alarms he set up or the team set up, in order before, let's say, sharing this with operation or with the rest of the mine site team, because otherwise you may end up with too high a number of alarms that could somehow risk to reduce the credibility of the monitoring system in general. Of course, there could be also another way you can discuss with the operation and try to understand in different areas what could be their, let's say, accepted alarms rate, which is something that we do in other situations where, or in specific areas, no? Because there are areas where you may accept a higher level of alarms because there are people that are working there. So even though it could be annoying to receive an alarm, of course, you have exposed workers, so it's important to timely notify any type of risk. In general, I recommend to let's say be transparent with operation and trying to say that at the beginning we have to learn. So give a kind of beta period for the initial setup of the alarm, review the alarm, and try to optimize them. For what concerns the second question, of course, noisy radar data are part of the alarms, because I typically experience it in several sites during, for example, period of time when you have significant changes in the atmospheric condition during the day. You may have, for example, in southern US, you may have the monsoon season. This is when you may have alarm triggered simply because you have a front of bad weather that is activating alarms. In that case, you have two options. One is, for example, to define different threshold for the different periods you may have. The same applies, for example, in Brazil, where they have a rainy season and dry season. Okay, of course, in the rainy season, you may expect to have more noise in your data, so it could be a good advice to have two, let's say, set of threshold for the two periods, or during the, let's say, the rainy season, the bad weather condition, to have always a geotech engineer reviewing the alarm before making it, confirming it, okay? Because if a human being with experience can take a look at the radar data, in the majority of the cases, it can really differentiate between let's say, bad atmospheric compensated signal or an actual acceleration going on.
I saw some heads nodding on that. Charlotte?
Yes, just to add to everything that Paolo said, and he explained so many of these concepts perfectly. I think just to add to that is if you get a new radar system, people think commissioning is just setting the system up and getting it scanning and then getting your training and then off you go. Commissioning a system actually can take a number of months because part of it is learning what alarms to actually apply, as we've already discussed, to that slope wall or that TSF or whatever infrastructure you're actually monitoring. So reviewing the database information, as Paolo said, and understanding what the background noise is or the concerns in that database is paramount. The other thing is most of our radar systems from all of the service providers have inbuilt warnings within them to say, for example, the atmospheric conditions have reached a point whereby it's compromising the ability of the system to accumulate movement. You would get a warning for that. And within your trigger action response plan, you need to have a portion of that trigger action response plan to say, for example, for the Reutech systems, it says the system has now entered what we call stabilization mode. That's basically a note to the user to say too much atmosphere going on, everything's compromised. We are at the point where we're going to wait for the atmosphere to calm down before we can continue to accumulate movements again without compromising the quality of the data. But you need to decide what are you going to do in that period of time whilst in stabilization scan. If it's just for a few minutes or for a short period of time, you might say, no problem, that's fine. But if it's for a very long period of time, you might say, I'm actually going to pull the team out, because technically when your system is in that mode, you are not receiving live data. You are actually monitoring. You're not actually monitoring. You're monitoring in the dark. You're not getting valid information in. So I always recommend having that component in the trigger action response plan to manage those kind of specific events, and then also keeping alarm logs of understanding what is an actual true alarm versus a more ambiguous or noisy alarm. And the other thing I also say is when you do get an alarm and it shows you where it is on the synthetic map, choose a portion that's quiet on the synthetic map. Look at the atmospheric data and actually look at the trend of the movement for that specific alarm to ascertain if the movement trend looks like it should or is representative of true movement, or if it's just true noise that's maybe following the temperature or the refractivity index, which is measured on the radar as part of the atmospheric type noise. I think one more thing to add to that ambiguous data component is, Paolo touched on it with the TSS. If you have slopes with vegetation on it, you are going to get false alarms. Other thing I call it is electromagnetic waveform housekeeping. If you have mesh or any kind of metalliferous object in front of the slope, anything that will interfere with the electromagnetic waveform transmit and receive, you're also going to get false alarms. So you need to make sure that you know where that kind of infrastructure is. So if you get alarms within that area, you know what it's actually from. It might not be from the slope. It could be the mesh, or it could be water at the bottom of your slope causing multipathing, that kind of thing. Thank you.
That's great, Charlotte. Thank you. Pat.
Hey, Jill, just a couple of things to add on that is with respect to the alarm fatigue and ambiguous radar data, et cetera, is that one of the things we've done at our operations is really emphasize the education part of this with our operational teams. We have developed a SOP for geotechnical incidents, if you will, that we sit down with the dispatch teams, because our radars are in dispatch, and educate them when we see these rapid changes in, say, atmospheric conditions that are influencing the radar performance. Great example, last night at 10 o'clock at one of our operations, I got a call from one of our teams saying, hey, what's going on? And we talked through it, refresh their memory about things like how the atmospheric conditions influence the radar data. But to help the operations out is make sure that you have a backup monitoring system. For example, in this case, we have robotic total stations and prisms. So we're able to look at both tools and say, all right, well, there was no precursor movement of the slope prior to this atmospheric change. And similarly, through the atmospheric change, the robotic total stations, the prisms, TDRs, SAAs, whatever you might be using, GPS units, don't show any issues that help you with your decision-making process in that TARP. And all of those things need to be rolled up in your TARP.
Very good point. Redundant systems.
Yeah, no, I was going to say exactly that. Redundancy is key. A couple of other things I scribbled down. Charles alluded to it. When you get a new radar unit, for example, a lot of them, the weather correction is done statistically. So it sort of takes a month or two, or it can do, before it really irons out those the alarms from pressure differences and weather changes and things like that. It sort of learns what your weather patterns are like, so that may take some time. So you might not want to alarm on it for a month or two. And the other one is the staffing capacity and capability. If you've got a big team that run a night shift and a day shift, and are able to look at these alarms and decide if they're real or not before any action's required, then obviously it's a lovely position to be in. Certainly here we're looking at a dedicated night shift now. That's something that we think is a real thing. I'm seeing it more and more across all sites, really. And then the other bit is, what is the actual risk here that you may be dealing with? Some sites typically look at 2 or 3 benches just above a shovel, and I'd have set very, very tight alarms on that. Other sites might be looking at walls that are 2 or 3 kilometers away, but if a little bit of slumping occurs and there's no mining there, then perhaps that's all right. So just take into account what that risk is and set the alarms accordingly. And yeah, you may well have to deal with so, a phone call at 10 o'clock at night or whatever, but that needs to be commensurate with the risk.
Yeah, I agree with everything that the rest of the panelists said. Maybe 2 other points. In terms of learning your slope and how long it takes to have calibrated thresholds, depending on the environment that you're working with, I mean, it can often take a full year to evaluate the seasonality and the impacts of the environment on a radar unit. I'm not saying you have to wait that long to set your thresholds, but to truly evaluate some of those seasonal influences, you need to have a pretty good body of data to pull from. And I guess the other point I wanted to make is that I am an advocate of having some alarms, even if they're false alarms, just to keep your monitoring teams engaged. I'm not saying something that's a frequency that you start to get that cry wolf mentality, but having something that prompts the team to look at the data and engage in the data and go through the evaluation process, I think is helpful as well, as long as it's reasonable. And it also supports that you're kind of right there on the edge of maybe having too many alarms or not enough alarms in terms of what your thresholds are defined as.
Great. Thanks very much, Derek. There is another question that's sort of in the same realm I'm going to pull up that we can touch on to continue this conversation on calibrating our radar data and also on environmental factors that may affect a performance. So we've talked about that calibrating your data to set alarms can take a number of months or longer. But how often is that perhaps reassessed to ensure accuracy and continued reliability of your radar data? And maybe our panel can also touch on if there are any measures that are taken to account for those environmental factors that can affect the radar performance And so I will open this up to our panel.
I think, Jill, just on behalf of all the radar service providers, the atmosphere is our biggest enemy. We are constantly looking at new ways to manage the atmospheric correction to ensure that we're representing the true movement of the pit slope. So regardless of what system you're utilizing, I can assure you that there is a team of software engineers working very hard in the background to try and get to the point that these environmental factors are managed as best as possible, you know, in the various codes and the various techniques that we're using. And I think just with the validation and the calibration, I'll hand back over to the more operational teams that we have on the panel to go through that.
Yeah, I think it's just an ongoing learning curve. I mean, certainly the radar, you know, the technology is so good now. Once something starts moving quickly, anyway, the chances are you're going to see it, unless maybe it's in the middle of a torrential downpour or a really big storm. You know, even if you're scanning at very long distances and there's pressure changes, the chances are you're going to see it. You've also got subsampling and all these other, and you can look at prism data over a long period of time to really identify that small scale movement. And there's also there's so many different radars out there, ones that can, you know, are much better suited for long distance scanning, and then there's more tactical units for perhaps monitoring above a horizontal drill or a shovel where you might not have quite so much warning time if you're in more of a brittle rock, steeper ground, and so on. So I think it'll be very site specific, and it really is an ongoing learning thing. And as long as the teams are aware of it, I think that's probably the key thing. And that's just one other thing is, I know that if in a big pit so one of our big pits, we actually divide it up into sectors. So you're not applying the same atmospheric correction for the whole pit. It's actually sort of treating each sector individually. And that worked quite well for us, because we may have clouds and everything in one part of the pit, and could be clear skies in the other part of the pit. So you don't want to apply the same atmospheric correction across the board, because it sort of messes things up a bit.
Yeah, definitely, Greg. We call those microclimates. We're quite cognizant of those when setting up different monitoring campaigns. All of the service providers provide options for managing the microclimates within a pit.
And Pat, did you have something to add?
A couple things. Yeah, I do, Jill. Thanks. Just a couple things to add on this is, one, know your pit or your pit. The Charlotte's point about the microclimates, at Cortez Hills open pit, for example, the way the pit was mined, it creates a dramatic temperature inversion between the hillside above and the pit below. So when we get into the rainy season or the monsoon season here in June and July, we get some significant changes in the atmospheric conditions right at that boundary. So you need to be mindful of that. And then secondly, this is another good example of where having redundant monitoring data is valuable. That data helps you validate whether or not your radar is telling you the right thing or not. You know, the robotic total stations and prisms, GPS units, SAAs, whatever your tool of choice might be for your specific conditions, take advantage of it.
Great, thanks, Pat. All right, I'm going to pull up another question from the live group here today. An interesting question that is asking, can a slope radar monitoring system be effectively utilized to monitor a high wall that is covered by overspill material? So I think I'll maybe ask Charla to comment on this, considering that she operates a radar provider. Have you experienced this type of situation?
All the time, and Tsepo, that is such a good question. There needs to be, I think, a few papers written about this and how to cope with this. Obviously, we know that pit slopes are constantly going through various phases of pushbacks or cutbacks, and there's so much going on, at any one time. Just look at your background picture for your presentation. I mean, there's so much going on in that pit. There's quite a lot to think about. So off the top of my head it's overspill material. So it's going to reach its angle of repose depending on the material itself, the fragmentation, the combination of the different size of the fragmentation. So whilst it's reaching that angle of repose, you have to also understand that any water or snow melt or anything like that is going to add weight to it. So it's going to change its behavior. So it's understanding a little bit of the mechanics and the behavior of how this material actually, behaves on the pit slope. The second thing to think about, and it's something that I actually learned from a lot of Derek's work that he did, is looking at the data coming in for that specific blast spill, okay, and then setting alarms based on the information coming in specifically for it. So you would kind of understand what the background movement or noise component is. And then, like Paolo said, look at a few standard deviations above that kind of rate and then start setting alarms for that. So I've monitored blast spill material. It's worked very, very well. It's shown pockets of movement of certain portions of it. What I would love to see, but I haven't seen, and I think maybe the operations can give a little bit of information on this, is dependent on how thick that blast spill material is sitting on the bench faces or the area that it's covered, is I've never seen movement take place of the slope behind it enough to initiate enough movement of the blast spill to indicate a much bigger kind of slope movement component. So yeah, just a few things off the top of my head, but a very, very topical question that I'm quite interested in. So looking forward to hearing what the other panelists say.
Greg?
Yeah, this is tough as well. I generally speaking, I would say I do everything you can to avoid spilling material down on a slope that you are concerned about. There's blasting practices you can do. You can design your blast in a certain way and cast it. You can dig in a certain way so the material doesn't come over. We've written papers on that. But if you are, for whatever reason, maybe the cut's narrow, so you don't want to load it out and it's easier just to push it off. For whatever reason, you're going to push material over, because obviously that is just the easy thing to do. It probably comes back to the failure mechanism. If you think there's a moving wall and it's more of a ductile mechanism, then maybe you can see it. I'm not sure I'd want, if I knew that I had a critical mechanism that was quite brittle and was potentially posed a risk to safety of the operation, I would do everything I can to avoid spilling material over, or just not have people at the bottom of it while you do that cut. I think it's a tricky one. I would avoid doing that at all costs, would be my comment.
Preventative measures.
Yeah, pretty much.
All right, we have about 10 minutes left in the webinar today. I will just point out to the participants that there have been some questions in the Q&A that have been answered in written form by our panel. So just make sure you go in there and click on the answered tab to see the answer to any questions that you may have asked. All right, I'm going to pull up, I think we might have time for 2 more questions. This is a pre-submitted question that came in through the GCE email asking, is slope monitoring data commonly presented to operators prior to work beneath an actively moving slope? And then I think I'll pair this in just with maybe quick comments on one of the live questions that came in on how to communicate with the operational team on an actively moving slope, on how long do they have until they have to isolate the area. So how long do they have until they have to isolate the area? How to determine that, how to communicate that, and do you present slope monitoring data to those persons working beneath a slope? So who would like to start with this? Greg.
Well, only because we are in one of our pits doing exactly this. We are mining below a wall that is just moving and moving and moving, and it to all intents and purposes, it's failed. But this is certainly, yeah, it's a really interesting one, and we've done this for operators, and some of them are really interested in this. They want to see the radar data, and they want that confidence and that warm feeling that, oh, look, all this stuff's being looked at. And some of them are really interested in it, actually. And some of them really couldn't care less. They're just not interested. They just want to do their job and go home, and that's fine as well. So I think it probably depends on the situation and the people you're dealing with. We'll often go to the lineouts. That's a great, in terms of a comms, when the shovel operators and haul truck drivers and everyone lines up in the morning, we call it the line out. That's a great chance to either stand up and just let everyone know what's going on, or educate the supervisor, and the supervisor can tell the teams. And then it sort of ties back to that very first question about simplicity. Just explain it in the nice, simplest way possible. Yes, we have good control. Here are the triggers. The triggers have got to be absolutely clear. The operator doesn't need to make a decision, and should never have to make a decision. It should be absolutely crystal clear. If you're operating below a moving wall, you are on that safety margin is high. There needs to be absolutely zero ambiguity as to what or should or should not happen. The alarms and the triggers are clear, and when the geotech team make a decision, that shovel operator just walks out. Okay. And there's other things you can do. You might queue your haul trucks outside of the moving area, and they come in and load one at a time, and that may raise questions. Operators might be like, well, hang on a minute, why is everyone queuing out here and I'm the shovel operator digging below this thing? So there is definitely that education piece, and that is important. But to some extent, I think it will depend on the operator themselves.
And are you relying on information like an inverse velocity for like a time to failure?
Yeah, and that we'll probably write a paper on this because it's been really interesting to do it. We do use inverse velocity, Jill. I don't think you can ignore that. When you will be digging and you might not see a slope response, but perhaps you get quite close to the wall, and that's when it starts to speed up. And maybe you can tolerate a little bit of acceleration. You walk the shovel away, and then it'll slow down, and then you can carry on. Or if it doesn't slow down, and that inverse velocity line starts to clean up, you just have to act on that. And we've done that, and we've evacuated the pit, and then it never collapses because it's already moving. So it can't, I'm not expecting it to collapse, but I just don't think you could. I think it would be very irresponsible to operate and ignore the onsets of accelerations and not do anything about it, just in case something did happen. Mm-hmm. And so there is a direct comms between geotech team and the shovel operator. You could just get on the radio and say, right, walk out. And there's contingency built into that. We have sort of 24 hours the reverse velocity. That would be our trigger for pulling things out.
So continuous monitoring, continuous communications, understanding your failure mechanism, all these things. Yeah.
Be prepared. If you're going to mine below an actively moving wall that's really deforming, be prepared for some difficult conversations. But it's not to say it can't be done by any means.
Any other thoughts from the panel on this question? Pat.
Yeah, Jill, just to add to what Greg was saying, one of the things we do at our operations is, not only do we speak at the lineouts, but our operational geotechs are at all the daily planning meetings. So any updates are communicated directly to the operation supervisors, so that if there is a change since the lineout meeting, that the operators can be updated. And we do present the slope monitoring data to the operators. We do take the time to educate them and have that conversation with them, so they understand what we are seeing, and we're able to talk through it. And one of the common sayings that some of our operational geotechs have revolves around the IDS radar units. Green is good. So when the ops guys go into dispatch, or they're in the lineout room and they can see the radar display, they can see that green is good, or hey, there's a yellow area or red area on that radar screen. Why is that? Can you help me understand why we're working under there? So really, as to Greg's point, education is really important. And you're going to have a lot of people that are interested, some that aren't, but give them the opportunity to ask questions. We also have at our operations a hotline number, so that people can reach out to the geotechs if they have questions. We prefer that they initially go through the supervisor, but if they have something that's really needs to be dealt with in a timely manner, I just saw some spill rock come down one of the benches or come off one of the benches. They can reach out and communicate with us. But ultimately, we do present the slope monitoring data directly to operators, so they understand where the conditions we're working under. As to the forecasting, we typically are, when we have a moving slope, we're using inverse velocity data, and we'll clear out at least 24 hours ahead of time, especially for very large failures, and find another place for the shovels to go. And this goes to the operational aspects of this. The operational geotechs really need to be tied in and tuned into what's going on, and having those conversations with not only operations teams, but the planning teams, so that if you have an expectation that you're going to shut down a complete layback or a portion of another layback, to minimize downtime and costs, that we've already been planning for a move to send the equipment to. Perhaps that opportunity may not exist, but we need to make sure that we are planning for that, so that we can minimize the amount of downtime. So once you shut that portion of that layback down, that they know where they're going, and they can get that shovel in an active dig phase.
Yeah, great points, Pat. All right, we have reached the 9 o'clock hour here in Arizona, which means we've run out of time for the webinar. I think that last question really, for me, cements the value of having good monitoring data, having a good monitoring program, having good communications between the geotechs and the operations, and just the really important job that geotechnical engineers are doing to safeguard everyone working within the mine. So for all of you listening, we appreciate that you want to learn more, that you're here in this webinar, and continue doing a great job at all of your sites. And the GCE is here to support your learning, and please reach out to us however we can. I want to say thank you so much to our panel today. You all are amazing. It's been a great conversation. I wish we had more time. We have more questions that came in we didn't get to. I would encourage you to reach out to the GCE, and perhaps we can connect you with one of the experts here today. As well, we have our radar monitoring course, which is currently available for registration. So you can take that course and learn more. It's online and available to anyone around the globe. So if you want more information on that, scan the QR code. And otherwise, we will see you in another webinar. And thank you so much again to our panel today. We really appreciate your time.
Yeah, thanks so much, Jill. That was great. I enjoyed it.
Thank you very
Yeah,
much.
thanks everyone.
Wonderful, everyone.
Thank
That
you.
was a great discussion.
All right. Thank you so much. We
Bye-bye.
will see you all next time. Have a great day.
See you.
Take care. Bye, everyone.